The drama surrounding the giant world of Jupiter begins with a simple but astonishing truth. This planet is enormous beyond imagination. Floating in the outer reaches of our solar system, Jupiter is so massive that more than 1,300 Earths could fit inside it. It's a swirling sphere of gas, storms, radiation, and mystery, a world so extreme that for centuries humanity could only stare at it through telescopes and wonder what secrets lay beneath its colorful clouds. But everything changed when a spacecraft began sending back revelations that shook scientists around the world. The story truly begins in 2011, when NASA launched a mission designed specifically to uncover Jupiter's deepest secrets. The spacecraft was called Juno. Unlike previous probes that simply passed by the giant planet, Juno had a much more ambitious goal. It would travel billions of kilometers through space and enter Jupiter's orbit, studying the planet from closer than any spacecraft ever had. The journey itself was epic. For 5 long years, Juno traveled across the solar system, navigating the cold darkness between planets. Then, in 2016, the spacecraft finally arrived and slipped into orbit around Jupiter. What happened next stunned the scientific community. From that moment forward, Juno began transmitting data that revealed a world far stranger than anyone had imagined. One of the first surprises came from a perspective humanity had never truly seen before: Jupiter's poles. For centuries, every image of Jupiter showed the same familiar view: colorful horizontal bands wrapping around the planet like giant stripes, along with the famous red storm visible from the side. But no spacecraft had ever studied the planet's poles in detail. When Juno finally captured high-resolution images of the North and South poles, scientists were left speechless. The poles looked nothing like the rest of the planet. Instead of stripes, they were filled with massive swirling storms, giant cyclones rotating in mesmerizing patterns. These weren't small storms like the hurricanes we experience on Earth. Each cyclone was enormous, roughly the size of the entire planet Earth itself. At Jupiter's North Pole, something even more mysterious appeared. 8 giant cyclones were arranged in a near-perfect octagonal formation surrounding a larger central storm. It looked almost like a piece of cosmic geometry, nature arranging storms with mathematical precision. At the South Pole, 5 cyclones formed a pentagon-like pattern around another central vortex. What baffled scientists most was their stability. On Earth, hurricanes form and dissipate within days or weeks. They move across oceans, collide with land, and eventually fade away. But on Jupiter, these massive cyclones have remained locked in place for years, spinning endlessly without merging into one another. No one fully understands how such a delicate balance is maintained. Some scientists suspect that Jupiter's immense rotation and atmospheric dynamics create a stable equilibrium that prevents the storms from colliding. Others think deeper forces inside the planet may be influencing the patterns. Whatever the explanation, the poles of Jupiter revealed that this gas giant behaves in ways completely unlike anything on Earth. And that discovery led scientists to ask an even bigger question: what exactly lies inside Jupiter? Unlike Earth, Jupiter isn't a rocky planet with a solid surface. It's classified as a gas giant, meaning it is composed primarily of hydrogen and helium. If you tried to land on Jupiter, you would never find solid ground. Instead, you would sink deeper and deeper through thick layers of gas that gradually transition into dense liquids under crushing pressure. For decades, scientists believed Jupiter likely had a small, solid, rocky core buried deep inside its atmosphere. But when Juno analyzed the planet's gravity field, the results revealed something unexpected. Jupiter does have a core, but it is nothing like scientists predicted. Instead of being a compact, solid object, the core appears to be enormous and fuzzy. It's roughly 10 times more massive than Earth, but rather than forming a clearly defined center, it seems to be a vast mixture of heavy elements blended with liquid hydrogen. Imagine stirring a giant pot until everything inside becomes partially mixed together. That's what Jupiter's interior may resemble. This strange structure has profound implications for how planets form. Traditional theories suggested that giant planets begin with a small rocky core that gradually attracts surrounding gas, eventually forming a massive atmosphere. But Jupiter's fuzzy core suggests something much more violent may have happened billions of years ago. One possibility is that early in its history, Jupiter experienced a catastrophic collision with another large protoplanet. The impact may have shattered the original core and mixed its contents into the surrounding layers, creating the diffuse structure we observe today. If that theory is correct, it paints a dramatic picture of our solar system's early days, a chaotic era where massive worlds collided like cosmic billiard balls. Yet Jupiter's mysteries don't end with its interior. Some of the most exciting discoveries lie not on the planet itself, but around it. Jupiter is surrounded by an enormous family of moons, more than 90 in total. Among them are 4 especially famous worlds known as the Galilean moons, discovered centuries ago by Galileo Galilei. These moons, Io, Europa, Ganymede, and Callisto, are some of the most fascinating worlds in the entire solar system. Among them, Europa has captured the imagination of scientists more than any other. At first glance, Europa looks like a frozen wasteland, a smooth white sphere covered in cracked lines of ice. Its surface resembles shattered glass that has been frozen in place. But beneath that icy shell lies one of the most exciting possibilities in planetary science: a hidden ocean. Scientists believe that beneath Europa's ice crust, which may be 15 to 25 kilometers thick, lies a vast global ocean of liquid water that could be up to 100 kilometers deep. Even more astonishing, the total amount of water in Europa's ocean may be greater than all Earth's oceans combined. But how could liquid water exist so far from the sun, where temperatures are incredibly cold? The answer lies in Jupiter's immense gravity. Because Europa orbits so close to Jupiter, the planet's powerful gravitational pull constantly squeezes and stretches the moon. This process, known as tidal heating, generates internal friction and heat within Europa's interior, much like bending a metal wire repeatedly until it becomes warm. That heat may be enough to keep Europa's hidden ocean from freezing solid. On Earth, life exists in the darkest depths of our oceans near hydrothermal vents. Entire ecosystems thrive around these underwater vents, feeding on chemical energy rather than sunlight. If similar vents exist on Europa's ocean floor, scientists believe microbial life could potentially survive there. This possibility has sparked one of the most exciting missions in modern space exploration. NASA is preparing a spacecraft called Europa Clipper, designed to study Europa in unprecedented detail. The mission will fly by the moon repeatedly, scanning its icy crust, analyzing its chemistry, and searching for signs that life could exist beneath the surface. If evidence of life were ever discovered on Europa, it would be one of the most profound discoveries in human history, proof that life is not unique to Earth. Meanwhile, Jupiter itself continues to display one of the most iconic storms in the solar system, the Great Red Spot. This enormous crimson storm has been raging for at least 400 years. It's so massive that 2 or even 3 Earth-sized planets could fit inside it. Winds within the storm exceed hundreds of kilometers per hour, swirling endlessly through Jupiter's thick atmosphere. Juno revealed something surprising about the Great Red Spot. The storm isn't just a shallow surface feature. Instead, it extends more than 300 kilometers deep into the planet's atmosphere. That makes it more like a gigantic atmospheric vortex than a typical storm. But there's another twist to the story. The Great Red Spot is shrinking. Historical observations show that in the 1800s, the storm was significantly larger than it is today. Over time, it has gradually become smaller, though it still remains enormous by Earth standards. Scientists are still unsure why this is happening, and no one knows how long the storm will continue to exist. It's possible that we are living in the final centuries of the Great Red Spot's life, witnessing the slow fading of one of the solar system's greatest storms. Another extraordinary feature of Jupiter is its magnetic field. Earth has a magnetic field that protects our planet from harmful solar radiation, but Jupiter's magnetic field is in a different league. It's roughly 20,000 times stronger than Earth's. This immense field traps charged particles and creates radiation belts so intense that they would be deadly to humans within minutes.
In order to survive this environment, the Juno spacecraft was built with a special titanium radiation vault to protect its sensitive instruments. Yet Jupiter still holds another lesser-known feature: rings. Most people associate planetary rings with Saturn, whose bright, icy rings are easily visible through telescopes. But Jupiter also has rings, thin, faint structures made of dust particles. These rings were first discovered in 1979 by the Voyager 1 spacecraft. Later observations showed that the rings are formed when tiny meteoroids strike Jupiter's small moons, blasting dust into space. That dust then spreads out into delicate rings encircling the planet. All of these discoveries lead to a deeper question: why does Jupiter matter so much to us? One reason is that Jupiter acts as a kind of cosmic bodyguard for Earth. Because of its enormous gravity, Jupiter often captures or deflects comets and asteroids that might otherwise threaten the inner solar system. A dramatic example occurred in 1994.